All right, so here's the general method for method of variation of parameters. V of P, variation of parameters. The way you do it is, suppose you have AY double prime plus BY prime plus CY equals to some function f of x. And then, let's say you solve the complementary solution and you got the following. Let's say the solution looked like YC equals to C1 Y1 plus C2 Y2. Okay. These are both functions of x. Okay. So I should be really writing Y1 of x and something like that. But you should know, right? Okay. And in this case, we can write down the particular solution as U1 Y1, U2 Y2, where U1, U2 are no more constants. It's a function now. These are functions of x. Okay. And then when you differentiate U1 Y1 prime plus U2 Y2 prime, and then the product rule also produces the ones with U1 prime Y1 plus U2 prime Y2. Okay, and then you assume that this is equal to 0. So when you do the second derivative, you only have to do this one, yp double prime equals to, again, U1 Y1 double prime plus U2 Y2 double prime, plus then there's this special terms U1 prime U1 prime Y1 prime plus U2 prime Y2 prime. Now, what happens afterwards? Oh, sorry, that there's something that I kind of messed up here. This should be 1. Okay, this should be 1. If this is 1,
Where was that?
A should be 1. Yeah. If it's not 1, then you have to divide so that it's y double prime plus something equals the other one. Okay. All right. So in this format, if you plug everything to the left side, what happens is that these, when plugged into the left side, they're going to cancel because it's the complementary solution. So, for example, y double prime plus b times y1 plus cy will become 0 because that's the complementary solution. Same thing happens this way. So at the end of the day, when you plug everything to the left side, all these will cancel away, and the only thing that survives will be u1 prime y1 prime plus u2 prime y2 prime equal to the right side, which is f of x. Okay? That will always happen, as long as you make this as 1. Okay? If it's not 1, then you should divide everything so that you get y double prime 1. Okay, and then you have u1 prime y1 plus u2 prime y2 equal to 0. And that's a system of equations. And surprisingly, you can even solve this using matrices. So you can kind of guarantee that this will always lead you to this. But you can also write this as matrices. And let's see how you can write this as matrices. So write it as y1, y2, y1 prime, y2 prime, u1, u2, prime, prime, equal to. Let's try to figure out what you get. This times this, what do you get? y1, u1 prime, y2, u2 prime. Which one is that? It's the second one, not the top one. It's the second one. So what do you put over here?
0.
0. Okay. This times this. What does that give us? That's the top one, right? So this is f of x. And once you have it in this form, now you can solve this matrix equation by taking the inverse of this, right? But what is the determinant of this? Do you remember this A, B, C, D inverse? A, D, no, dA, negative B, negative C, right? divide by the determinant, right? So if you apply this rule, you end up saying u1 prime, u2 prime equals to 1 over the determinant. But what's the determinant of this? That's the Wronskian, okay? Of y2 prime y1, negative y2, negative y1 prime, times 0 times fx. Okay. So you can use this as a formula, compute the right side, find u1 and u2, u1 prime and u2 prime, and then you integrate. That's how you can find out the u1 and u2 quickly. Okay, so you can, if this is too much, you can just memorize this one and use it, or you can also just memorize this one.